Alright, let's take a look at example 35. We'll start with 35a. Right, so in example 35a, we are given that the real part of z is equals to 3. So we know that if we were to rewrite z in terms of the x plus iy form, alright, so we can actually see that x is equals to 3. So x equals to 3 is just a vertical line at which passes through x equals to 3, right? Right, so the locus is actually can be easily drawn. Now for B, you are given real part of z minus 2 imaginary part of z is equals to 4. Again, you know that your z, alright, can be written as x plus yi. So the real part of z actually refers to x, and the imaginary part of z actually refers to y. So therefore, you can actually reduce it to this form. Alright, so for this particular locus, alright, we can just draw the straight line. Right. Mind you that you have to use ruler, imaginary, real, and this is the line. So that is part B. Now let's take a look at part C and D. For part C, alright, you're given the equation of the form imaginary part of z plus y equals 3, and we know that if we were to rewrite z in terms of the x plus iy form, alright, you will be able, alright, to notice that y is just equals to 3. So in order for you to draw this locus, it is very simple. Right, so there you go, the simple example in part C. Now how about part D? Right, so similarly in part D, you are given imaginary part of z minus 2i is equals to 3, and you know that if you were to rewrite z in terms of x plus yi form, you will be able to get y equals to 5, and this will actually give you the vertical line y equals to 5. No, sorry, the horizontal line. So this is y equals to 5. So there you go. Alright, example 35 is actually quite simple.